Okay, we're back to some more technical stuff. I'm going to talk about Apptainer. Before I do, let's talk about what problem it solves. So let's say you need to test code on more than one machine. How do you guarantee that they're the same environment? So why would you need to test code on more than one machine? Let's say you're on a team. You have three people on your team. You're testing an algorithm. It takes a long time to run. You want all three of you to run it on your machines at the same time, or you want to do something on the high performance cluster. So how do you guarantee that the installed Python libraries are the same exact versions on all these machines? Well, can't we just run an install script that, for example, reads the requirement.txt file? Well, you could do that, but it doesn't necessarily guarantee that the versions will be the same, because libraries we depend on might be updated to new versions. Well, you might counter with, we can just nail down those versions in our requirements.txt file by specifying we need this exact version. Now, what happened to my project was we learned that sometimes those libraries that we depend on, they have dependencies that aren't nailed down, and we can't change that. So what would happen would be that we'd run the install and our system would break and we'd lose a day. And so that's the problem that Apptainer is designed to solve. And yeah, so let's see. What is Apptainer? It used to be known as Singularity, and that changed recently. It became Apptainer when it was taken over by a different organization. It's a container technology, kind of similar to Docker. Docker is kind of architected as a stack of things to try to replicate environments, but Apptainer is a single large file. And oh yeah, so Docker is not allowed on the cluster due to security concerns, at least at the time of this writing. And so Apptainer lets you build something that freezes the environment in a read-only container. They install Python libraries and everything else. And it becomes a single file that can be passed around and used on different machines. It is pretty big. In our project, it was like 10 to 12 gigabytes. So it can take a while to pass it around if you're working from home. But it really is a solid way to make sure that everybody's running the same code. Because if you're not all running the same code and your algorithms do different things, you have no idea if it's the code or what. So very important. Okay, so let's see. What do I want to show you? I'm going to show you an example. Container definition file. So I'm just going to give a quick tour here. So this is a .def file. It's Ubuntu Python.def. So this def file specifies a container that only contains a version of Ubuntu and a version of Python. And let's take a look here. So it actually bootstraps it from the Docker landscape. And we say, this is what we want. So it pulls in that. And then we have these %sign declarations. There's a number of them that you can have. So the environment here, this environment variable will be in play when the container is running, when you're running code in the container. The post declarations are the instructions for how to configure the container. What installations are you going to do? So here we can see that we do like some basics up here, get wget unzip curl, miniconda comes in, and installing the Python version. So this is just a basic container. It doesn't have any of our code, but the reason you use this is that if you build this once and you have this basic container, you can build a more complicated container, or rather a container that has your stuff in it based on this. So it's a faster build. You don't have to build the whole thing every time. This is already a file that can then be imported into the next build. And I'll show you an example of that. So let's, here. Yeah. So here we're bootstrapping from the local image, and we're getting the file that's the ubuntu_python.sif file that already exists because we built it once. And this is where we start. And so then we build stuff on top of it, and we have more environment declarations and configuration stuff going on. So here, I'm doing things. Let's see. I added some nice comments here. I added a private key for a GitHub authorization, put the correct branches into play, stuff like that. Install the Python dependencies, position the models, and so forth. Now down here, there's a run script. So you can specify a run script. And when that comes into play is when you're using the container, you can say Apptainer run, and it will automatically go to this script and run it. So this script will be inside the container. And this declaration is how Apptainer will remember how to find it. And here you can see I'm accepting a couple of arguments. So this is a way that I can pass choices of what I want it to do at the command line when we're launching the container. So what else to say about Apptainer? So Apptainer is a read-only file. You can't write into it. So what this means is that if you have code in there that needs to write stuff, where is it going to write it? Well, there's two different directories that are automatically bound into the container, and that is your home directory and /temp. So in addition to running the container, you can actually instead shell into the container to look around the container. So you would say Apptainer shell space name of your sys. So you would say Apptainer shell name of your sif file, and then the prompt you would get is from inside the container. And so once you're in there, if you listed out the contents of /temp or tilde, it would look exactly the same as if you were outside the container and listed those directories. So those are the writable by default directories in Apptainer. You can bind additional directories in by specifying that in the def file. I don't have examples of that, but you can bind additional ones in. But when I was using this, I decided to simplify things and just have my run script copy the image of code that I had on board in the container out into the home directory. And then I ran it from there, and then it could write everywhere it wanted to under the home directory. So that was kind of a hack that I did to make it so that I didn't have to tinker with all the code to make, figure out where everything was being written to and make adjustments. So I think that's all I'm going to say about Apptainer. I just wanted to give you a quick introduction that it's something that's out there that might be helpful for you depending on what project you land on and what you're needing to do. It does add a little bit of complexity, but if you are going to need to test stuff in parallel on different machines, it is the way to know that you are for sure having the same code running everywhere. Okay, we'll see you at the next video.